I'm going to be juggling some things during this. And so if it doesn't go smooth, which means it won't go smooth, bear with me. I have a demo I'm going to run. And so when I run that demo, I can't run it on a simulator because I'm going to be interacting with the Bluetooth antenna. And so I have QuickTime showing my device, but that makes things interesting sometimes. So bear with me. But yeah, just some quick background about me. I've been doing mobile development since 2011. It was primarily Android development from 2011 till 2018 or so. And then around that time, I started doing iOS development, and that's all I've been doing since. And around that time also, I started working on a project with some people on this call, I think, but that had a large piece of the app was dealing with Bluetooth. And so it's Bluetooth low energy. And so that was a lot of fun. So I figured I would give a talk about some basics. And so, yeah, I put the question mark here after demystified because maybe at the end of this, it'll help, but maybe you guys will also be very confused. So with that said, ask questions along the way. This doesn't need to be just me talking. It can be, but that might be pretty boring. I'm not too funny. And so, yeah, please ask questions along the way. I don't mind that at all. So yeah, some expectation settings, because that's what I'm all about in my life, is setting the bar low. So let's go ahead and do that. This is going to be pretty basic stuff. It's nothing advanced. I'm not going to discuss things like frequency hopping. I don't even know what that is, but I was asked about it, I think, as a joke. So I won't get into that. In-depth hardware details. Yeah, I'm not a hardware person really. I find the whole IoT space like really interesting and fun, but that's not really my thing. So we won't go into details about that unless you all want to and the conversation goes that way. But and also Hedy Lamarr, I didn't even know anything about her, but I guess she did a lot of stuff, research and into things that was like the foundation of Bluetooth. I learned that today. So we won't go into depth about the history of Bluetooth to that degree either. So yeah, what we're at a high level, what we'll talk about today is some definition and concepts of Bluetooth low energy. I have a demo, I wrote an app, and so I'll go ahead and show that. And then I'll do a bit of a code walkthrough, which kind of goes a little bit more into the core Bluetooth API. So you guys can see, so everyone sees some working, which I think is always pretty useful to do. So yeah, so the first thing I think when, if you don't know too much about Bluetooth, I think most people just think like, hey, I've got a headset that connects to my phone or my car or, something like that. So that typically people are referring to classic Bluetooth, which if you want to get even more detailed, there's I think there's like 3 or 4 different specs that all clump into classic Bluetooth. And that's like an area I don't know too much about, but a rough timeline here. The Bluetooth spec has been updated over the years, starting around 1999. Bluetooth 1.0 was released, all the way up to 2010, Bluetooth 4.0. It's still being developed. I don't remember what version they're on right now, but the important bit for this talk is 2010 is the first time the spec included Bluetooth low energy. Oh. 1999, there's a lot of people that probably were born after that. I feel like I'm getting old. Let's see here. So there's Bluetooth low energy. That's what we're going to be talking about. The key thing with Bluetooth low energy is that, as the name implies, it consumes a small amount of energy. I would love to put like a number on that, but there's none out there. I think it just varies peripheral to peripheral, but it just doesn't use much energy at all. For example, a lot of peripherals might run on the little coin batteries or whatever those are called. And they can run for a very long time on that, depending on how the energy is being used. And also depending on the peripheral, the user doesn't need to manually pair with the device. So it won't show up in like your system settings. If you go to your settings and then Bluetooth and navigate in there and you see a list of Bluetooth devices, you don't need to go through the rigor for that. Kind of go into that a little bit here. Also, just kind of comparing the two, just a simplified comparison between the two. Bluetooth low energy is going to stream small amounts of data, and so just some examples like heart rate monitor, some beacons. There's a whole lot of peripherals out there that are more like custom, I guess, to the manufacturer, but they stream small amounts of data. contrasting that to like classic Bluetooth, where you'll be streaming like audio or video. Although I have also been reading that in the newest spec, there is a Bluetooth low energy audio. I really don't know anything about that. That sounds kind of interesting to me. So, but anyways, yeah. So I'm gonna, like I said, I'll keep flying through this stuff. If anyone has any questions at any point, please feel free to jump in and ask. So yeah, some real high level stuff right here as far as it pertains to iOS and Bluetooth. The API is called Core Bluetooth, and at a pretty high level, there's a couple objects you'll be interacting with. It's a central manager and a peripheral. The app I actually built two apps, so I kind of fibbed a little bit. I needed to interact with the peripheral, and so I just made my own peripheral. I didn't really realize this, but with Core Bluetooth, there's also a peripheral manager. So I'm not talking about it much in this slide because I'm focusing more on the central side, the central manager side. But you can also create your own peripheral. And this is like a convergence of awesomeness with Apple. I thought this was pretty sweet. So I wrote this app in SwiftUI, and SwiftUI you can run as a Mac app. Hey, sweet. So just wrote this app in SwiftUI, and I ran it on my laptop, and my laptop is now a peripheral. That's pretty sweet. It didn't take long at all. I thought that was really nice. So then I can control the data that's going into the central, which will be running on my phone. So back on the central side of things, just a little bit about the hierarchy that you'll be dealing with Core Bluetooth. You have your central manager, and then underneath your central manager, or maybe not directly inherited or anything, but you tend to scan for or discover peripherals. A peripheral will be like any device out there, like a heart rate monitor, beacon, just depends on what you're working with. And then within a peripheral, there's going to be a collection of services. And a service is basically a collection of characteristics. As you can see in the diagram here, there's multiple services, so it's an array. And then within each service, there's also an array of characteristics. We'll get into more of those in a little bit. But that's just the general topography. I think if you can remember that, that'll make the rest of this talk and the concepts a lot easier. So connection types. There's two different ways to interact with a peripheral via Bluetooth Low Energy. One is via advertisement data, and then another one that I'll get to in a little bit is you can actually connect to the device. So in advertisement data, as the little picture there shows, the peripheral at certain intervals will be broadcasting out some data. It's literally data in iOS terms, but it's a byte array. And so I don't remember the exact frequency, 20 milliseconds or so, let's just say, it's pretty quick. It'll just keep telling anyone who cares what's going on. That might be very up to the peripheral. I probably shouldn't say that. The peripheral probably could control how often it advertises. But it's a small amount of data, and any central out there, speaking from iOS terms, any central can scan for advertisement data and interpret it and decide what to do with it. You can also, like I mentioned, you can connect to it. And that gets into, I had always called this a GAT connection. I don't know if that's proper terminology, once I started looking into it a bit more. GAT is an abbreviation for a generic attribute profile. And that's just the specification for how a peripheral will advertise its data, essentially. At least that's how I say it. So yeah, it defines the format of the services and the characteristics. That's kind of what I was referring to earlier. And it defines the procedures to interact with those attributes. That's a pretty dry example. We'll show more of it later. Typically, when you're interacting with the Bluetooth Low Energy, you'll be establishing a connection and interacting with it that way. You can, like I said, you can scan advertisement data, and you can do a fair amount with that, but typically you're going to be establishing a connection. There's also a concept of bonding. I'll admit I don't know too much about this, but I think it's probably a fundamental thing. So if you look into Bluetooth low energy, you're going to run into this. So when you bond with another device, this is when your peripheral will show up in your settings in your devices. You're exchanging keys, so that way the operating system remembers that peripheral. I don't want to misspeak about this. I think the bonding is up to the peripheral if it supports bonding or not. And so not all peripherals will. And so that doesn't mean you have to go through the bonding process. If the peripheral does support bonding, the workflow, people here probably have seen this. There's a few different ways that this can be done. You might have seen where you try to connect to a peripheral and you have a pin that you need to input. More commonly, you might see just a simple yes or no. So you launch an app and it tries to connect to a peripheral, and then you get a system dialog. Hey, would you like to connect to this device? Yes or no. And then also bonding can be done just totally under the surface, unbeknownst to the user. One thing I did get into in the last project a little bit, not so much me personally, but thought it was important to mention, is Core Bluetooth doesn't provide any insight into the bonding process. So as a developer, you don't know if bonding has taken place or not, which can be a little awkward for the user experience. And so there's been some blog posts out there on how to get around that, to know if something's been bonded or not. This kind of gets into, I see a hand being risen. Yes, question, Vui?
Yeah, I wasn't sure if you went over what the difference between connected and bonded was, or if I missed that.
No, I didn't. You're correct. I didn't, because I don't honestly know why you would prefer to have one over the other. I think, like I said, I think it's driven by the peripheral on whether or not you need to bond with it or not. So I don't know if you really have a choice. I could be misspeaking on that. I do know that if you bond, then the operating iOS remembers the peripheral. If you don't bond, then it's just app specific. It's up to the app to then remember that peripheral and then reconnect to it.
Okay, so like bond is like gives you additional information about the device to help with connecting next time.
Yes, I will say yes to that. That makes sense to me. Brendan has his hand raised too, and I think he might drop some knowledge here. So yes, please, Brendan.
I was just going to say, I've had it, the only time that I've been presented with Core Bluetooth to want to pair or bond with a device has been when I want to subscribe to a characteristic. So if I'm not subscribing to a characteristic, so in other words, I query all the characteristics for values myself, it doesn't bond. I don't get presented with that UI. So if I want the system to inform the application, like in a reactive way, like, hey, this value was updated on the peripheral, then it does a bonding.
I see. Yeah, and I did read a little bit about this too, and it seemed like Apple had a recommendation, and like I said, I didn't spend too much mental energy on this because I wasn't focusing on it too much, but their recommendation was like a minimalist approach, kind of like what Brendan was talking about there, which is you don't prompt the user until you try to access a characteristic that's encrypted, and then at that point it will then prompt, the operating system will prompt the user. But it's up to the manufacturer, the peripheral or the firmware to decide that, is my understanding at least. So thanks, Brendan. Does that help, Vui? A little bit?
That helps a little bit, thanks.
Cool. Yeah, sorry, this is where the demystified question mark is key, because hopefully we can help some, or maybe we just can have more questions when we're done. Yeah, so this is just, again, the kind of like the Russian doll like nesting kind of thing here that you have to work with Core Bluetooth, which is you start at your central manager, where you can deal with one or many peripherals, and then from the peripheral you can deal with I should say zero or many services, and then within a service, you can deal with zero or many characteristics. But typically, you're discovering on down from high to low. The central manager, that's just a object-oriented representation of the central device. Central device, oftentimes in our world, being like if you're writing an app, your phone is the central device, your app, and so that's what they mean by central there. Usually, your app is interacting with a peripheral. And yeah, that's initialized before. So you have to initialize the central manager to do anything, pretty much. It's the main object there. The peripheral is just representing your actual peripheral. And so the very first thing that you do, sorry, Brendan, your hand's still raised. I assume that was from before, or is that new?
No, it is. Oh, Lord, there you go.
Thanks. Yeah, so the first thing that you typically do with your central manager is you ask it to scan. And the scanning is going to pick up that advertisement data that I mentioned earlier. So any peripheral around is going to be advertising data. And so typically the first thing you want to do is scan for advertisement data to discover peripherals. If you were to ever run an app where you start scanning, typically you're going to find way more than you'd probably expect. Because I think just even in an individual's house, there's a lot more Bluetooth devices than maybe people realize. If you're in an office, you're going to get totally inundated with Bluetooth devices. So you need to do certain things you can scan for certain peripherals. There's ways to help filter that. But the other thing is a peripheral contains that collection of services that I was referring to earlier. There's more to services than what I mentioned here. I just kept it simple, which is services is a collection of characteristics. It's up to the peripheral and the firmware on the peripheral of how those services group those characteristics. I would say that typically they should be kind of like logically grouped, but basically it's a collection of characteristics. Characteristics is what you ultimately are going to be interacting with quite a bit, I would say. And so the characteristic contains a single value and a number of descriptors, potentially, I should say, a number of descriptors that describe that value. But characteristics are what you're going to be reading to, writing to, and subscribing to. So this is where you're going to get the rubber meets the road. You're going to actually be doing most of your work. And that's it for the key concepts. And so before doing like a code walkthrough, I figured the best thing would maybe just to show you a working example. And then from that, we can start walking through some of the code. So hopefully this will work. Go ahead. So just real quick at a high level, like I mentioned, I have two apps, two workspaces here. One is for the peripheral. And so you can see I have this peripheral manager. I'm not going to spend much time going through this unless people are curious. I definitely can walk through it. It's pretty short. There's not too much going on. But what this app is responsible for doing is just creating a peripheral that's running on my Mac. And when I run it, you can see I have a Swift UI view that is extremely complex. It just says hello world, because I don't think there's any point to a UI for the peripheral here. So, but either way, it's running. And so I had already ran that. And you can see I just have some login and it's advertising some data. So I'm gonna flip over to this project. This is the one that I think we care about a little bit more. And this is the central side of things. I have a few views in here and whatnot that I can go through at some point. But for the time being, most of or all of the Bluetooth work, I just put it in this BLE manager class, just to not to try to say it's an architectural decision that's awesome. This is just for demo purposes. So I'm going to go ahead and run this guy and pull up QuickTime here, and hopefully this will work well. Pull this down here. All right. So as you can see, the app's pretty bare bones simple. I've got an exciting title there to capture people's attention when they use this, and a button. And so that button, when I tap that, is going to start scanning. So that's me telling Central Manager to go ahead and start scanning for peripherals. So I'm going to go ahead and do that. You can see some logging in the background. I started scanning. I'll get into this more later on. You can scan in a few different ways, but just speaking to two different ways. One, you can scan where if it finds a peripheral, it won't find that peripheral again. And then another way you can scan is where you can scan it and it calls it allow duplicates. And I am allowing duplicates. So it's not that my house has this many peripherals over and over. It's fine. You can probably maybe see, but there's some duplicates in there. And so all of the peripherals that are found, I'm listing in this table here. This UUID is the UUID of the peripheral. I'll get into that later also. The number that's kind of changing on the right over here is the RSSI. That's the signal strength of the peripheral. And the peripheral that I created, I gave it a name of Hello World. And the name apparently is restricted by length in bytes. And so I didn't dig too much into what that is. Anyways, all it says is Hello World, and the D got cut off. So bear with me. So I'm going to tap on that guy. And so now under the covers, what happened is I selected a peripheral that I wanted to connect to. And so I told the app to go ahead and connect to that peripheral. I also told it to stop scanning. That's something that you have to control yourself. So I stopped scanning, connected to the peripheral, and then I went through and discovered all of the services. The services on this screen are sections. So you'll notice they have, the services have identifiers as well. So that's the headers up here. Sorry if that's hard to read. I realize it's a little like black on black now, or gray on black, but the UUIDs up there are the identifiers to the services. And then within each service, I also discovered all the characteristics. And so that's what the rows are. And so like this service right here has two characteristics with it. And I'll get into this in a little bit, but this, since my Mac is my peripheral, I don't fully understand this, but it's exposing some characteristics of the Mac itself. The characteristics that I created is this guy right here. This thing that ends in B0. I can go ahead and show that actually. You'll notice I'm over in my peripheral, the code for my peripheral right now. And so I created these services that end in right here, B0, 1, 2, and 3. I ended up not using 1, 2, and 3. So sorry about that. I need to clean the code up. But either way, it's this B0. And so that's this guy. And then the other thing is I created two characteristics, an echo characteristic and a timer characteristic. And those end in E0 and E1. So that's this guy and this guy right here. So I'll go ahead and demo the echo characteristic. So I'm going to tap on this row. That brings me to this screen right here where I have the ability to read and write to that characteristic. So just if you remember earlier, I mentioned with characteristics, it has a value. And depending on how the peripheral is set up, you can either read to them, write to them, or subscribe to them. And you can see over in my code over here, I set them up to this one, the echo, to be readable and writable. And the timer characteristic, I set up to be readable and you can subscribe to it. So in this case, hopefully this works. I feel like it's been flaky a little bit, but I'm going to go ahead and write a value. And what this is supposed to do is send that value of hello on over to the peripheral. I don't see it working because I don't see, there should be a log statement over on the peripheral over here that says it was written to. So I'm going to go ahead and stop both of these and try again. So bear with me here. There's the peripheral. There's the app. Oh, also, I don't know why this is the case. Maybe someone on the call, if they know. Sometimes my peripheral advertises not with the name I gave it, but it advertises with the name of Mac. I don't really know why. But. All right, let's try this again. So I'm going to go ahead and write a value. You'll notice on the peripheral side, I'm just logging some stuff and I got some data hello. And so now if I tap, I'm going to tap this read button up here. And you'll notice on the peripheral, it's saying, hey, I got a read request. And then it sent back to my central, my app, the data, which is hello. So I'll go type one more thing. Hit enter. So I sent hello world. If I tap read, hopefully it'll come back. I've noticed sometimes the reads take a little bit of time, which kind of surprised me. So there you go. So there's hello world. So this is on the peripheral side, I wrote it, I just called it an echo characteristic. It does nothing other than what I just did. You send a value in, it stores it, and then when you hit read it, it returns that value. And then this other one's a timer characteristic. What I did there is I just started up a timer and it just increments and you can observe it. So in here, I'm gonna go ahead and tap start observation. And so I'm not interacting with the app anymore. So this is just demoing what the notify characteristic can do, so you can subscribe to it. And so every second, the peripheral is updating the value. And when it updates that value, it notifies anyone that's subscribed to it what that new value is. So the peripheral, or the central, which is running on my real device, is getting this data from my Mac just through an observation. And that's pretty much the app. So go back to here. Is there any questions about that before we walk through it?
Yeah, and I'm sorry, I did have a question earlier, but I was trying not to interrupt.
Oh, sure.
Yeah, yeah, I wanted to ask you if you can bump up the text.
Oh, yeah, shoot, sorry. Oh.
And then there's a couple of questions in the chat I've been keeping my eye on.
Oh,
and
sorry, I have not.
Yeah, Novelty had a question: can one simulate peripherals? I guess.
Can one simulate peripherals? I don't know how to simulate I guess it depends on what you mean with simulate. The only way that I could simulate a peripheral was by writing my own, which is this guy right here, and running it on my Mac. Because do you mean like within the same, like you have a simulator running in a central and then also maybe a simulator running a peripheral, like all on the same computer?
Let's see.
Yes, that's what I mean. Not that I know of. I don't know of a way to do that. So the tricky thing with Bluetooth stuff is, like, if you really want to, like, the only way to really test it is you need it to actually use the Bluetooth antenna. So a simulator cannot use core Bluetooth at all. So that's why I'm running this on a real device, because I need to actually have a real data come into the Bluetooth antenna, if that makes any sense. But yeah, that was part of the tricky thing with setting up this demo, is I had to try to figure out a way to have a peripheral. I was looking at buying a peripheral to interact with before I realized that I could just write my own, which was kind of nice. So
I also have a question. Yeah, I didn't do this, so maybe this dumb question. So for the Bluetooth low energy, do we suppose to have a board a subscriber like a publisher? I mean, what's your publisher? What's your subscriber here?
Let me pull this up here. I might have to reconnect. Oh, hold on. Well, okay. So by that, do you mean when I was subscribing to my timer and it was updating every second? Is that what you're asking about?
Yeah. So basically, I just want to make sure you understand the, what's your broadcaster, what's your listener. Yeah.
Okay, gotcha. Yeah, I will walk through the code in a little bit and I'll go into more detail on that. And hopefully, if I don't answer your question then please, yeah, let me know at that point.
Okay.
Is there any other questions here? Yeah, Light Blue is a nice app for testing. I've used Light Blue quite a bit. That's a good point. Is there any other questions that I may have missed?
Yeah. Is it possible to create a characteristic on the fly, like while the Bluetooth device is running? I mean, I know most Bluetooth devices are hardware, but you have one running in software here.
On the fly. I don't know if I follow. Like, so,
I mean,
so right.
I mean, like, let's say you have this service running, right? Can you add a characteristic to it while it's running?
So like dynamically, like someone someone writes a value to one characteristic, and then based on that, I create another characteristic.
Potentially, yeah, or just add new characteristics over time, like.
I do not know. I've never. No, well, hold on. So you're getting into the peripheral, which I don't know as much about, but let me just take a look here. Here's how so I'm on the peripheral side, not the central side. When I created my peripheral manager, I had to tell it the characteristics. And so maybe what you would, so I think the answer might be no, because you have to like tell it all the characteristics. And if you tell it all the characteristics, then you're not really adding any on the fly.
Yeah, I had a suspicion that was the case, because most of the time, you know, your Bluetooth device is just a hardware device that doesn't change, right? But because you do have the option here in software, I was just wondering if there was some sort of, I don't know what you would use it for. It's just the thought occurred to me.
Yeah, I don't think you can. Yeah, I'll stick with that. I don't think you can. Yeah, any other questions? Cool. All right. Well, we'll jump through some of the things I did to build that app. I don't go into all the detail, but I think I try to hit the Bluetooth stuff specifically here. So the very first thing you're going to need to do, and this is kind of nasty. If you don't know about this, you'll hit the snag, and it'll catch you off guard, and it might take some time to figure out what's going on. But you need to add the privacy permission here to run it. So you need to let the user know that you're going to use the Bluetooth antenna and why. So in my case, you can see I added a very descriptive comment of for demo purposes. And so this will pop up when your app first launches. And they have to say yes. If they say no, then you won't be able to use core Bluetooth, or I'll show you in a moment, but there's a state that Central Manager will be in. I didn't do this for the demo app, but if you intend to use core Bluetooth in the background, which is probably a pretty common use case if you're using core Bluetooth. So like if you're scanning while the app is backgrounded or maintaining a connection, you're going to need another permission here. So just be aware of that. Even if you don't remember exactly these permissions, I think if you just remember that you do need them, then you'll at least know what to search for. All right, so creating a central manager and instantiating it. I'll walk through the code again after I'm done with these slides, especially if there's some questions, but it's pretty simple. This is how you instantiate it, where you pass in a delegate. In my case, I just made it myself, of course. I'll go ahead and forget the exact name of that. That's come down here, the CB Central Manager Delegate. And so it, of course, has various callbacks, but here we go. So that's, in my case, self. And then queue is the dispatch queue where you'd like your work to be done on. In my case, I passed nil, which means the immediate queue, or the queue that I'm on, I think. Let me just double check that. Forget some of these options. Hold on 1 minute. Where do I create it? Right here. If nil, if the value is nil, the central manager dispatches central role events using the main queue. Yeah. So because my app is very sophisticated, I use nil, so I'm just using the main queue. That may or may not be what you want, but just keep that in mind. So monitoring the state of the central manager. This is taken from the demo app here too. One of the callbacks of that delegate is this central manager did update state. You can't really do anything, so like scanning, for example, until your central manager is in a state of powered on. That's the bottom one down there. And so as soon as you instantiate your central manager, it's going to call this function here and let you know what the state is. If you don't have, if the user said no with permissions, I mean, it's been a little while. I think what happens is it comes in this unauthorized state here. And so you have a means to do something in the code to handle that scenario. It shouldn't be ignored because the user's totally allowed to say no. Maybe your app is still useful if they say no, but either way, you can do something to handle that scenario. So scanning, this is how you scan. Again, it's I think what you'll find is Core Bluetooth is pretty simple to use. There's options. So like in here, there's these options. And so like you can get into details, which can be confusing. At least to me, it can be confusing, but at a high level, it's a pretty simple API to use. So to scan for peripherals, this is all you need to do. You just call central manager.scan for peripherals. You can pass in an array of UUIDs for the services. So if you remember, a peripheral has a collection of services. If you pass in nil, then what will happen is it'll search for every single service that peripheral offers. You might think that like, hey, that's the way to go. I mean, I always thought that was the way to go. You know, go ahead and search it and bring them back to me. And if I don't want them, I'll ignore them. Apple docs recommend against that. They say it's more of a hit on the battery and it could take more time. And anything with, if you're connecting to a peripheral and you're scanning, a lot of this kind of happens in the connection phase. And so anything that takes more time could be apparent to the user. So it is something to keep in mind. In the case of this demo, just because I'm trying to just demo all the services that are found, I just kept it nil. And this is the options here. There's more than just this option, but it's what I was referring to, where I allow duplicates. And the reason why you might not want to allow duplicates is just to filter out the noise. Like you might want the peripheral once and that's enough. There's no point in being told that you found a peripheral 10, 20, 30 times the same peripheral that is. In my case, the reason why I wanted to be told that there's duplicates is because the RSSI value changes. So if you remember in my app, the signal strength was changing in that table where I was listing my peripherals. And so each time the same peripheral comes in, the RSSI value may or may not change, but I wanted to know that so I could display that. When you are scanning, you're going to more than likely get some results. That comes back in this delegate callback. Did discover peripheral. It gives you the central, the peripheral, the advertisement data, and the RSSI. And so in the case of my demo, all I'm doing is just like collecting the peripherals. That's what this peripheral subject is. And sending it to the UI, more or less. I can walk through that in more detail. But the point is you get the peripheral right there and you can do whatever you'd like with it. In my case, I'm just adding it to a collection, essentially. Oh, I should say, I actually created this, you can see in there, I created this peripheral wrapper. And that's because the peripheral itself does not contain that RSSI value. The RSSI value is separate. So I just created this wrapper object that contains the peripheral and the RSSI. So now you've scanned for a peripheral and you've found some, presumably. So you can go through and you probably would want to connect. I'm going to take a moment. Looks like there might be some questions. Any tips around this if you're handling the Bluetooth connection? Maybe. So you want to let the user know what's going on. I guess I would say that. And so any sort of like animation or whatever. So typically what happens is you scan first, and because you don't know if the peripheral. So I'm going to operate under the assumption that if you're building an app, you're probably wanting to connect to a specific peripheral. And so in that case, if you know you're going to scan and you're going to have to find a way to filter out all the peripherals to find yours. And that process could take some time. And so you probably want to have some sort of user experience where you're maybe like animating, or maybe the user taps a button, kind of like I just had on my app, a start scan. And maybe you'd want an animation that you're searching. And you probably would only want to scan for a certain period of time, let's maybe like 5 seconds. And at that point, if you don't find the peripheral, then you can let the user know, hey, I can't find your peripheral. If you do find your peripheral, then at that point you need to connect, which is what I'm about to talk about here. I would say typically that connection probably should happen behind the scenes under the guise of like scanning. You know, a user probably doesn't care all the intricacies about how to establish that connection. And then once you're actually connected, then you could probably let the user know, hey, we found your peripheral and we're connected. That's the happy path. There's the unhappy path where they say no to using Bluetooth, or, oh man, there's so many. I didn't throw this under the tips slide, but a user can, let me just give you an example. Hold on 1 second. Hold on a second. This up. I think this will come through. So a user can swipe down right here and tap on Bluetooth. And you would think that's turning it off. And oh man, it's been a while. This doesn't actually turn your Bluetooth antenna off. It like, I forget the details. It sleeps. Brendan could give more info. But the point is, if you do that, then your app won't be able to access core Bluetooth to do the scanning. So you would need to handle a scenario like that. So there's a lot of scenarios that you might need to keep in mind that a user could do where they can't scan to find their peripheral. I don't know if that answers your question about best practices, but I would say just be as transparent and helpful to the user as you can. Hold on 1 second here.
I have a question regarding the scan. So you said that if you scan every peripheral, Apple would not recommend because that's consumes too much energy. So what's the best solution to find all your peripheral?
So scanning, let me change my slide here. Hold on 1 second. Hold on, losing control. There we go. Go back up to scanning here. So, so their recommendation, oh my gosh, these windows with chatting. I'll leave that up. Their recommendation is that with services where I put nil in there, is that you do not use nil, that you specify the service UUIDs that you're interested in. If you don't do that, like with nil, it's going to scan for any peripheral, regardless of what services they have. If you give it a collection of UUIDs, and the UUID is the identifier of the service that you're interested in. And so the typical use case is, let's say you're building an app for a very specific peripheral, maybe your company owns it. And so you have access to the firmware documentation, and your peripheral has a certain a service or services. And so you can add that as an array right there, those UUIDs that you know. So you'll be hard coding those UUIDs in, they don't change. They're defined by the peripheral. And so when you scan for those, then it's only going to give you back those peripherals. And that's a little bit easier on the battery, and you're only going to get peripherals that you know you care about. So that's their recommendation.
Okay, thank you.
No problem. And let me close that so I can scroll through here. Abhi, is there a reactive way to access core Bluetooth instead of using delegates? I hope someone can prove me wrong here, but I'm going to say no. And that Apple does not provide like a combine wrapper or even like an async await or anything like that. It's just the delegates. And I'll pause for a moment in case someone wants to correct me on that. And I'd be so happy if someone did, but I'm pretty confident that's the answer. Dang.
What's question? I didn't get it.
Oh, sorry. So Abhi had asked, I know this text might be a little small, but it's in the chat. He said, is there a reactive way to access core Bluetooth instead of using delegates? I should say the way I interpret that is a reactive way, like combine. It's a reactive framework. And so instead of using delegates, using something like combine or maybe even async await, that's the way I interpret the question, at least.
Yeah, that's right. Yeah.
And Apple does not provide a combine or async await interface to core Bluetooth. It's just the delegates. So you would have to build your own reactive way.
Yeah, I saw in your code, I think you added some publisher sender that you already built yourself, right?
Yes, I'm using Combine in my demo app, and I can show that in more detail, of course. But yeah, that was me. All right. I don't know why I'm losing keyboard access here, but okay. So I think I was at connecting. So I'll speed up a little bit here, but yeah, so connecting, yeah, you just do central manager.connect. So previously when you were scanning, you got those peripheral objects back. And so you'll want to keep a hold of those peripheral objects however you want. And then as soon as you want to connect to it, you just call connect. I will say you will likely want to set the delegate on the peripheral. It's a different delegate than what we were dealing with before. Now we're dealing with a CB peripheral delegate. And so it has callbacks that are specific to that peripheral. It has some options that you can connect with as well. I don't remember those off the top of my head. I remember looking at them and thinking, oh my gosh, that's quite detailed stuff that's beyond the scope of a basic talk. So I'll move on. And yes, I wanted to take a quick tangent about peripheral identifiers. I've kind of mentioned them a couple times. If you work on a project, especially if there's an Android application, this topic will come up. Inevitably, what's going to happen at some point, someone's going to say, hey, I need the MAC address of the peripheral. You know, maybe you're a product owner, or so there's going to be some sort of requirement that says we need the MAC address of the peripheral. Maybe you're sending data to a backend, and that backend wants to uniquely identify that peripheral. And so a MAC address is a way to do that. And on the Android side of things, you can get that MAC address. However, with core Bluetooth, you cannot get the MAC address at all. Apple does not allow you to get the MAC address of a peripheral. Instead, what they do is they provide you a UUID that's meaningless outside of the app's context. So as soon as you scan for that peripheral and you find it, it'll generate a UUID for you. And like I said there, it's meaningless outside of the app's context. And so the important thing that means is if you get that UUID and tell your backend like, hey, here's the UUID of this peripheral, that's going to be useless to anyone. You know, it's only so if some other app tries to connect to a peripheral with that UUID, it won't work. And so why did Apple do this? You know, Apple's the worst. They're just being a pain in our butt. No, well, maybe. But it's intentional. It's a security or privacy concern. So they do that because they don't want developers to have access to that MAC address. So just the way to protect the privacy of the user. So, you know, maybe Google's the worst then because they don't care about that privacy. Totally joking there. But I figure, you know, this isn't an Android meetup, so I could do that. But I am bringing that up because in the real world, what will happen is you very likely might be on a team with both Android and iOS, and that's something that you might need to address. There's education that needs to happen with that. People might not understand why you cannot get a MAC address and why you may need to have workarounds for that, and it might take more time. And so if a MAC address is needed, you know, for one reason or another, one thing that you can't, there's a few workarounds, but the peripheral is able to provide that MAC address itself. It can do so via within the advertisement data or via a characteristic. So if it's a characteristic, you basically connect and then you read the value of that characteristic and poof, you have the MAC address. But that would be the peripheral intentionally giving out the MAC address. It is not via core Bluetooth. Hopefully that makes sense. So services, to discover services. So the peripheral on it has a services property. It's a collection of services, and it's going to be nil. when you first discover your peripheral. That's important to know. It doesn't come with it inflated, so to speak. So you have to discover the services. And so to discover the services, you just call discover services, which is pretty simple, I thought. And this is similar to what I said earlier about scanning. I passed nil in my demo, but typically, if you know what services you're interested in discovering, you'll want to pass those IDs in. So that nil is could be an optional array of UUIDs. And so you'll want to pass those in so that it just saves battery life and time. To get service results, you have this delegate callback here. It's did discover services, and it gives you the peripheral. So the important thing here is it's not giving you a collection of services, but it is giving you that peripheral, except now that peripheral, the peripheral.services, that services object will be inflated with any services that were found. So then the next thing you'll probably want to do is discover characteristics. And so for every time you get that callback that we just had about discovering a service, you'll probably want to say, hey, for this service, I also want to discover the characteristics. The pattern is very similar. It's also quite simple. And so same thing with characteristics. You can pass in an array of the identifiers. And the same thing, the Apple recommends that you do that because it saves battery life and time. And getting the results back of that characteristic is a very similar callback. You get the did discover characteristics for service callback. And so now, and you also get the peripheral. And so now at this point, your peripheral.services is inflated with whatever services were discovered. And also the services.characteristics, which were nil previously, are now inflated as well. So you have to jump through some hoops in order to discover these things. Subscribing. Link, I think this gets to the question that you were asking earlier. So now I'm going to get into the characteristics and how you subscribe, read, and write. And so to subscribe, all you do is you tell your peripheral, hey, I want to set a notification value of true for a specific characteristic. And so that's going to enable subscribing. And so for my timer characteristic, that's what I do. At that point, you're going to start getting data anytime the peripheral sends out new values. And so this is how you observe changes. And so there's two callbacks really. Anytime you set up a notification or disable a notification, you get a callback in this did update notification state for characteristic. That's not giving you any like real data other than that you can interrogate that to know if you're notifying or not. The callback you're probably going to be mostly interested in is this did update value for characteristic. And anytime, so assuming you're observing, anytime the peripheral changes the value of that characteristic, it's going to notify the central, which is, this app, and this callback gets made. And so you have the characteristic right there, so you can interrogate that characteristic for the data. And then once you have that data, you can do whatever you want. In the demo app, I did put a combined framework in place to interact with my view layer. So hopefully that answers your question. So reading is pretty similar also. A read is a one-time operation. So unlike subscribing where it's like a data stream, so to speak, reading you just get, you tell it to read a value once and you get a value back. So you call this read value for characteristic. And getting the results back, it's that same callback actually, did update value for. So this callback is used for both reading and for notifying. And then writing characteristics. So you can write data to the peripheral as well. And that's via this write value. And so the value is just data. And if you remember, data is just bytes. So once you're working with core Bluetooth, Bluetooth Low Energy, get ready to work with, get back to your binary math days. You're dealing with bytes. There's no nice like JSON wrapper or anything like that. You're dealing with bytes. So you have to, any objects that you have, you're going to have to serialize it back down to bytes. And then when you're reading values back from the peripheral, you're getting bytes back as well. So you have to know how to take those bytes and transform That could be really fun if that's your thing. And if you have the time, it can be so extremely frustrating, even if you like it, but you don't have time. So just keep a heads up on that. There's two ways to write a value. You can either write a value to the characteristic, and then you can see the parameter on the right side there with response or without response. Without response will be done quicker. So if you're going to be writing values very fast, you may want to write without response, because with response will slow you down. So for example, if your central is sending a file over to the peripheral, you might want to do without response, because there's limits to the amount of data that you can send over, data limit lengths. So you're gonna have to send a write command, I don't know, 100 or 1,000 or whatever times. And so you might want without response. Typically though, you're gonna do with response, so that you know that the write was actually received. And when you do get a response, you get this did write value 4. That's the callback that is called. And so that's pretty much it for the code. I can pull up the, just want to respect time. We're at 1 o'clock right now, Eastern time at least. So we're an hour in. And so I figured I could either walk through the code and answer questions and let you all drive it a little bit. Oops. So I'm going to close this and pull up questions, and I can walk through the code in more detail. Pull up this chat. Any questions? What are some real life examples of characteristics? Like what might be a character radio of a Bluetooth enabled radio? I don't know about a Bluetooth enabled radio, but let's say like a heart rate monitor. Maybe you're getting or maybe even a blood pressure monitor. I don't know if that's like a theme, but just making it up. A characteristic might be like blood pressure, which is, well, shoot, I'm not a doctor. I'm really bad at the blood pressure and exam. There's 2 numbers or something. There's like a high number and a low number. So maybe you have a characteristic for each. And so like you might observe those values as you're reading your blood pressure. That's an area where I would think subscribing to that value might be useful, because as it's reading, it might be changing until it eventually stops. But that'd be an example of a characteristic. Yeah, hopefully that's helpful.
So characteristics are things that you're watching for changes in? Correct.
Yeah.
Okay.
Yeah. So another example, let's just say you have I don't know, let's just say a toothbrush. And so let's say as you're brushing your teeth, maybe you want to know like how long you've been brushing your teeth. And so there might be a characteristic for brush time. And so you can, as you're brushing, maybe it tells you how long you're brushing, and maybe it updates every second, something like that. Could be another use case of a characteristic that you're subscribing to. Your device, also another example, just making this up, but like your device may have some LEDs, let's say, and maybe you want the user to change the color of those. And that's an example where maybe you would write to a characteristic. So you'd have an LED color characteristic, let's say, and it takes in a byte value of the RGB, values. And so the app on a color picker maybe like picks a color, you convert that over to the bytes, you send that on over to the character. So you write to that characteristic those byte values, and then the peripheral takes those byte values and sets the LED on the peripheral. That'd be an example of writing.
And then maybe like, I don't know if we want to use the radio for an example, but maybe if you're like, getting to the end of a song or something like that, that could, send that change of data. I don't know, that would be a good example.
Yeah, so like metadata, maybe about like the next song, something like that.
Or could be, I don't know.
Yeah, I could see that. I will say typically anything with like a radio that's streaming audio is done with classic Bluetooth, except they do have that Bluetooth low energy audio, which I know pretty much nothing about. But
yeah, I don't know much about Bluetooth radio either. So maybe that's a terrible example to dive into.
Brendan, I see your hand is up.
Yeah, I was just gonna say, it might be helpful to like, you can use an analogy for a characteristic as a path on a URL. So, just any web service could have an infinite number of paths. And those paths are usually defined by some sort of business logic. It's the same with a characteristic. So a characteristic is really, it's analogous to that. So like, you'd have some path on some API that you would call. It'd be the same way with a characteristic.
Yeah, I like that analogy. I see some people are dropping off, which is, we're an hour in. So I'll just go through some tips I had real quick before going through code or anything specific. But and this by no means is exhaustive. There's a lot of, once you start working with it, you can get to a lot. But one thing I will say is a peripheral can only connect to one central at a time, but a central can connect to many peripherals. Some of these tips might seem like maybe simple or obvious, but oh my God, they'll burn you. So like what'll happen is you will have your peripheral connected to your phone where you're developing, but then maybe you use light blue. Someone mentioned light blue as like another app that you can download for free to help debug Bluetooth. So maybe you actually connected it to light blue in order to debug some things, but then you later on launched your app. And now all of a sudden your app's not connecting to your peripheral and you go, holy crap, what did I change? And you go into a rage. And then 30 minutes later, after banging your head on the desk and not noticing any changes to your code and thinking, what the heck did I do? You realized, oh my God, light blue is hanging onto the GAT connection in the background. And that goes back to this first tip, which is a peripheral can only connect to one central at a time. And so you go, oh my God, and you kill light blue and then you run your app and poof, it works. So I just point that out because it's never happened to me at all. A central manager can only have one scan at a time. That is pertinent because it might seem obvious also, like why would you try to tell your central manager to scan more than once? It kind of makes sense that it can only do it one at a time. That's another thing that can be tricky, just depending on your code base. It could maybe be easy for your code to accidentally call scan twice, while, especially if there's maybe like an error scenario and maybe you didn't stop the scan, but it's still scanning. Somewhere in the app thinks that it's not scanning. You tell it to scan, your app will actually crash. That's no bueno. And so that's no good at all. So that's just something to keep an eye out for. There's no standard API for firmware. And so how characteristics and services are arranged and how the data gets to and from the peripheral is going to vary, totally dependent on the peripheral. So you're really beholden to the documentation on that peripheral. Hopefully it's good. So just keep that in mind. Yeah, I said expect the unexpected because you just don't know. You have no clue how the firmware is written. And you will need documentation. If you don't have documentation, you can't really do much. And then debugging issues can be tricky because you've got a lot of moving pieces there. I mean, even in my case, I said my demo app is a little flaky at times, but it's hard to figure out exactly where the issue is. So you've got a peripheral that's running firmware on one side over there, and then your app is running your code over here. It's going over Bluetooth. And so when things don't work, you also have your app logic. And so it's tricky to figure out what's going on. But if you're curious if it's a Bluetooth issue itself or in your Bluetooth layer, try to eliminate all of that, anything in between the two. And that's where that light blue app can actually be very useful, because you can use that light blue to interact with the characteristics and services. And if it works, then at least the issue isn't with the peripheral, more than likely at least, and that the issue is within your app. So debugging can be a little tricky, and just expect to devote some time to that. Yano?
Back to the no standard API for firmware. Have you ever had to or tried to like reverse engineer a peripheral's communication, like using characteristics and stuff?
Not to like discover the API, but Yeah, the last project that I've been on that you probably know nothing about has documentation that says there is a behavior that should happen, and then you run into this. Kind of gets into the last tip too about debugging, but where the behavior is not happening as you might expect, and so then there's a bit of reverse engineering going on to try to figure out what's actually going on with the firmware. In an ideal world, it'd be lovely if you have access to the firmware devs as closely as you do as the other, like, app devs, or conceptually you can think of your peripheral as like a backend server. So like backend dev, if you have immediate access to your backend devs, then it'd be really nice if you had access to firmware devs like that. That can really help close the loop with that quicker. But
I have a question. You said the peripheral can only connect to one central at a time. So if the blue app, you said blue app will use to as debug, but you can only connect one. So how can you use blue app in that case? What's the best workaround for this?
So yeah, you just need to have that, keep in that mind. So like if you want to use light blue to interrogate your peripheral, you need to make sure that your peripheral is not connected to anything else. So if it's connected to your app, you would just need to kill your app and then open up light blue. And then if you're using it with light blue and then you're ready to use it with your app, you need to kill light blue, or in light blue, tell it to disconnect. There's no way to connect it to, so you have to make sure that it's disconnected.
Okay.
Yeah, is there any other questions?
Yeah, I do have like do you have recommendation for where we can get like a tutorial for this? I mean, for like a starter,
Yeah, so I'll go ahead and post. I'll update this slide that I just showed here to include the URL to the project that I have here, so that people can pull it down and play with it. You can criticize my code too, because it's pretty thrown together. But as far as a tutorial, so I put 2 whole resources up here, and that's not exhaustive because, man, I pulled up probably like 10 blogs in the process of doing this, but each one's got a little piece. But these I thought were extremely useful. So one's just the Apple documentation, and I'll admit I make a mistake sometimes of skipping Apple documentation and going to blog posts, because the blog posts can be easier to digest. But blog posts often overlook in details that are very important, and so it is worth reading the Apple documentation. Basically, don't do what I did, which is skip it. Go back, like actually read it. I know that's, and the other thing is the Apple documentation looks like it's dated, but there's so much. Even just doing this demo, I learned things. I'm like, holy crap! Like I totally should have just read all this stuff to begin with. So yeah, I don't overlook Apple documentation on that. As far as a tutorial, Punch Through, which is the company that creates that light blue app, they have a guide that walks through a lot of what I just talked about. And so as far as the tutorial goes, I actually thought that was really good as far as a basics tutorial. And so that link is right here also.
Okay, so if for this link, if I download your code, I can run it myself, right? Connect to the device.
Correct. Yeah, it'll be 2 repos, because one is the peripheral manager repo and the other is the central manager repo. If you just download the central manager, it'll work. You don't have to download my peripheral code. It's just that then at that point, it's just scanning for random peripherals and trying its best to interact with them. The peripheral manager that I wrote was useful because I can control what the peripheral is doing, which was nice from a demo perspective. But yes, you would be able to download it and run it.
Thank you.
Yep, no problem. Check the chat here. Cool. Well, I probably won't, just for the sake of time. I don't want to keep people here. I don't know how many people are on. Unless there is a desire to, I could go through all the code here. But the pertinent Bluetooth stuff I went through in the talk. If I go through the code, or if you pull down the code yourself, once I post the link out there, you'll notice, like we kind of mentioned before, I have to communicate with my view layer, I created a reactive layer in between, kind of. And so as I'm streaming in data, it's I'm putting them on these subjects so that my view can just react to it. My point being, I don't want combine in my implementation to confuse you with Bluetooth specifically. That's just how I decided to communicate to the view layer. So I tried to keep it this outside of that as simple as possible. You'll see I just have very simple functions that the view layer calls when it wants to read a value, write a value, or subscribe. It's really just doing one line. And then the delegates is pretty much what I showed you in the slides. So they're pretty straightforward. But you can play with things like when I started scanning and I didn't pass in any values, I just used nil. Where do I do that? Right here. So like the with services, if you pass in an array, you'll notice that right away you won't find as many peripherals. So yeah, feel free to play with it. But unless there's a desire to, we can go through the code more if there's any specific questions.
Yeah, you can. I'm interested in go through the code. I mean, if somebody do not like it, they can drop. Yeah.
Okay, sure.
Adam, did you post the link to your repo? I missed that.
No, not yet. I need to do, actually, it's still local. It's in a Git repo locally, which is useless to everybody. So I need to push that up to GitHub. So I will do that. And I think we can put a message in the meetup chat.
If you can,
And then I'll also put the slides out there, which I'll put a link to the repos and the slides too.
that would be great. Thanks.
No problem. So yeah, so you'll notice in the app, I won't go into the view too much, but I have 3 views. I have, oh my gosh, I don't want to try to get my previews working unless they just work. But my content view, that's the root view where I just have that scan button. And then, yeah, here you go. So you can see this, that's this view. I have my peripheral view. See if it works. It might not show any data. This is where I'm listing the table of all the peripherals that were found with the RSSI. Oh no, sorry. This is the peripheral detail. So the content view lists the peripherals in a list, and when you tap on one of those peripherals and it finds all the services and characteristics and displays them on the screen, that's this peripheral view. And then once you tap on one of those characteristics, that's when it pulls up this characteristic view. You'll notice I just have the buttons on the read, write, and submit. And I won't go too much into the view layer because I love Swift UI and I can talk people's ear off about that. I think the main thing is this BLE manager, which is, as you can see, it's just injected into every one of these views as an environment object. And the BLE manager is just a place to stuff all the Bluetooth stuff into. And so in here, you'll see I've got 1, 2, 3, 4, 5 various different publishers or subjects. And that's just a way for me to communicate to my view layer. You'll see here's that peripheral wrapper I talked about, where it's literally just the CB peripheral and the RSSI. When this BLE manager is instantiated, and the first time Central Manager is called, that's when I instantiate it. I just made it lazy for the sake of a demo. And so this is not saying that to replicate this code, but so this is how you start the Central Manager. Because it's lazy, just by calling it, we'll instantiate it. And so the view layer will call start central. And then that's when really when I hit start scan, I probably could have done that too. Either way, the button start scan will then start the scan. It calls this right here. And then I get the callbacks down here. So when the Central Manager is instantiated, that's when this is called. In my case, it goes straight to powered on because I didn't really explore the error cases. When you start scanning, it comes into this callback right here. Anytime I get a peripheral, I'm putting it on this found peripheral subject. Come back up here. Sorry, I hate scrolling around when I'm demoing because I know that can be a headache to people. But whenever I find a peripheral, it comes on this found peripheral subject where I'm assigning it to this peripherals publisher, which is, oh my gosh, it's been a little bit since I've looked at this. Oh, where got that? Hold on. So that's this, it's a set of peripheral wrappers, and it's a published property there. Anyways, that's ultimately getting back to the view layer where it is displaying all those peripherals in a table. The user can then tap on one of those rows, which is a peripheral. And when they tap on that, that's calling this connect, where the UUID of that peripheral is passed in. I want to make sure I'm not connected to anything first. So assuming I'm not connected to a peripheral, I'm going to go ahead and get that peripheral. And by peripheral, I mean the CB peripheral. I'm setting the delegate of that peripheral to myself, and I'm calling connect. And then at that point, I also navigate into the next screen. So let's come down here. You get this callback right here. This central manager did connect to a peripheral. And so this is where I start doing that chain where I'm trying to unwrap all the values. So I'm going to start just trying to find the services, and then for each service, I'm going to try to find all the characteristics. So right here, you'll say for the peripheral, I'm discovering all services. And then that comes back down into the peripheral delegate, the peripheral delegate callbacks. So here's the did discover services. And you'll notice for each, so this gets called when the services have been discovered. So now you'll see right here, peripheral.services. This is an optional collection of services. So before you discover them, this is nil. And so theoretically, after you discover them, it's going to be not nil. So I just want to make sure they're not nil. And assuming that's the case, for each service, I want to discover the characteristics. So, so that gets called however many services we have. That's when you get into this did discover characteristics callback. So each time a characteristics is discovered, or characteristic, I should say, is discovered, it comes into here. That's where I have this publisher for services. And that's, again, just to communicate back to the view layer. Where am I calling? Discover. Oh, that's discover characteristics. That's right. So then that gets into, and that's pretty, so now at that point, the app's discovered the peripheral, the services, and all the characteristics. And then these callbacks right here are for reading, writing, and notifying. So that's on the next screen where the user is allowed to tap a button and they can read a value, write a value, or notify. So that's a little bit more of a detailed walkthrough. Hopefully that's helpful.
Yeah, it's really helpful. Oh, by the way, to run your code, all I need is just iPhone as a peripheral, right? I do not need other low Bluetooth and energies device, right?
Yeah, just an iPhone running 13 or higher. There was permissions changed. I think it was on 13. And so if you're running something older, I didn't address it because I am assuming, I probably should mention that, but assuming most people were 13 or higher. So, but yeah, if you just download this code or pull this code down, you should be able to run it on your phone.
Okay.